Today we are going to learn how to tell if a relationship is proportional by looking at a table and also by looking at a graph. Situations where the unit rates are always the same are called proportional relationships. This means we can use unit rates to tell the difference between proportional and non-proportional relationships. Let's review what a unit rate is. It's called a unit rate because it's going to be how much of a quantity you have per unit of the other quantity. You've actually heard of a lot of different unit rates in your lifetime. You might remember miles per hour. You might think of dollars per hour if you're talking about salary or how much you get paid. You might think of dollars per pound or in general price per item. These are all unit rates. We use the unit rate to better compare if something is a good deal or not, if we're getting paid adequately, or how fast we're going. Unit rates make things more easily compared. Let's look at this example. Can you tell if 4 pounds of candy is cheaper than 5 pounds of candy or not? Not really just by looking at it. You need to figure out how much it costs per pound. So we do that by division, and you probably actually do this naturally. But for the sake of this, I'm going to tell you a unit rate usually has where you're dividing the dependent variable. I'm going to write this down somewhere. The dependent variable divided by the independent variable. So you got to think which one of these probably depends on the other. Well, I can determine how many pounds of candy I buy, but not the price I pay for them. So I'd say price depends on pounds of candy. So we're going to put price on top. And you probably could have done that in your head. You could have just been like, oh, it should be dollars per pound. So you don't always have to remember what I tell you as long as you are figuring out the right unit rate. So we're going to divide those two numbers to find out the unit rate. All right, 1308 divided by 4, 327. So I found 327 as my unit rate, but labels are super important because that tells you what that 327 means. So when we divide, our bottom is always going to end up being 1. So this is 327 for 1 pound, but you don't have to write 1. I feel like just writing pound is good enough. So this is 327, and our other unit was dollars, so I'm going to put dollars there. So we found that it's 327 per pound. Now we can find what that is for all these others to find out if it gets cheaper when you buy more pounds or not. So I'm going to just write my work for all of these real quick. I put the dollars on top and the pounds on the bottom. And when you enter this into your calculator, hopefully it's obvious that you don't have to enter in the units, you just have to enter in the numbers. But when you write it at the end, you should write the units. Okay, when I divided all these in my calculator, I actually got the same number for each of them. You can check me and see if I'm wrong, but this is what I got. So $3.27 per pound on each of them. So the whole point of today is that we're determining if a relationship is proportional or not. So, is this situation proportional? Well, if we look above, we found that situations where unit rates are always the same are called proportional relationships. And this unit rate is always the same. It's always the same amount. So we're going to say yes. And the price per pound is always the same. Or the unit rate is always the same. Works too. I'm actually going to write what it is. It is always $3.27 per pound. Okay, then what happens if we add this purchase? I'm going to write my fraction, 48.75 over 15. Let's divide that in my calculator. 48.75 divided by 15, and I get 325. So the number I got was 325, but remember I need to put my units. This should be dollars per pound. And you could write it like per pound like this. It's just, I'm a math teacher. I like writing things as fractions, and it is a little easier than writing out PER. So 325 is different than 327. And we said that proportional relationships, the unit rate always should be the same. And it only takes one data point that's wrong to make it not be proportional. So this is not proportional. Okay, let's look at this one. What if this 15 pounds didn't exist and we had $0 and $0? Well, if you think of proportional, hopefully last year you learned that a proportional relationship can be represented by y equals kx, i.e. you always multiply the number of pounds you have by the same number, and that tells you how many dollars it will cost. So, but if we put 0 in for both of those numbers, it doesn't matter what our k is. Like, it doesn't matter. And when you divide this, you'll actually find 0 divided by 0 doesn't come out to a number. It doesn't work. But this data point won't affect whether or not it's proportional because you can multiply it by anything. So this is going to be yes. So y equals kx can still be true. The only thing is we can't tell just by looking at 0, 0 if it's proportional. We do have to make sure that the other data points are the same number. All right. So let's look at proportional relationships. This might be a review. We're going to put in the table and find it from the table the unit rate, as well as figure out a way to just look at the graph. So generally when we're finding the unit rate, we always put y on the top and x on the bottom. And the reason why, actually, we've also made it so that y is the dependent variable and x is the independent variable. Once again, you might have learned this in another class too. It's generally pretty much the same anywhere you go. The independent variable will always go on the x-axis, which is this left and right one, and then y-axis is here. So we have this table, but we don't have all the data points in yet. We need to find out what these are. And we can find those from our graph. So I'm going to go over here. Let's change colors. And I'm going to go on the x-axis to where x is 0 and find out what y is. Well, it didn't go up at all, so our y-coordinate is also 0. And on the x-axis, let's go find 3. If you don't have numbers on yours in a future problem, just remember positive is always to the right. And y went up 1. And then x 6, y went up 2. Now let's go find our unit rate. On this one, I'm going to put y over x. Might help to always write this out for yourself. And I get -2 over -6. When I divide that, I get 1/3. Now 0 over 0, remember that's not going to work, but it doesn't show whether or not it's proportional. So we need something else to figure out if it's proportional. 1 over 3, hey, that works, and then 2 over 6. Now, you may be tempted here to say they're all the same, but remember that if this number were anything other than 1/3, then it would no longer be proportional. This one is proportional, so we're going to say, yes, it's proportional. The unit rate is always 1/3. And if you notice, this relationship is represented by a straight line. You can graph lots of things on graphs, but we're going to see a lot of straight lines in this unit. Let's see if this graph is proportional. Let's go ahead and find out what each of these are. I'm going to speed up this process a little bit. So here's my x-coordinate, -4. Here's where it is on the blue line, and that's -4. My y-coordinate, -3, is here. So that's -2 on the x-axis. 0 is -2. And then my y-coordinate is 1 because it's up, and so that's going to be here on my line. you may notice that it's way easier to find it left and right than to find it up or down. I don't know. That's just how I feel about it. Okay, let's go ahead and find our unit rates. We're going to divide y over x. This one gets me 1. Y over x. This one gets me 1.5. Hopefully you should already know that this is not proportional. This one won't divide. I'm going to show you what they all equal just so you can show, but around this point, you already know it's not proportional because those unit rates are not the same. So it's not proportional, and the unit rates aren't the same. Okay, so if you look at our graphs, they actually look very the same, but one was proportional and one was not. So maybe a thing you might notice is that this top one goes through the middle, the part where the axes cross. That's called the origin, or 0, 0. So that's one thing that we need in order to tell if a relationship is proportional. It goes through 0, 0. Here's the other thing that both of these actually have, is they are both straight lines. So first, it must go through 0, 0, and second, it must make a straight line. And now you don't even have to make the table. You can just look at it and go, oh, that's proportional. Oh, that's not proportional. All right, so hopefully this helps you out. Good luck.